So now that we have the closest section to our ship, it is going to be super easy for us to decide which track sections to render, right? Because, well, let me just remove first this printf statement because I don't need them anymore. Let's just hope that we are loading these sections correctly, right? Inside our ship section, we have the closest section to that ship, which means that whenever we are in our main function and we ask to render our track, let me just remove this draw axis here. So this render track function, it cannot be based on that distance check for each section, right? So do you remember how we have in our track.c, right here, render track, we go and we loop all the sections checking their distance with the camera, and if it is within this value, we go and we ask to render the track section. This is not how we're going to approach this anymore, right? So we are going to have now the ship start section, so the closest section to the ship, and then what we're going to do in our simplified version is we're going to render the track ahead of the ship, right? So all the track sections in front of the ship. So just to make sure that we know what we're doing and we know that this is different, let me just change the name of this function. Instead of just render track, let me just say render track ahead. So now this function is going to be called render track ahead because we only want to see the tracks in front of us. And in our track.h, this is render track ahead, and right here, render track ahead. Which means that I'm going to remove all this distance check logic that we have, no more. And what do we have to do? So we have to loop the sections in front of the ship. How do we loop the sections in front of the ship? Well, we're going to trust that the linked list was loaded correctly with the correct order of the sections one after the other. So this is basically going to say, we're going to start our current section. So current section, we start with the ship section, right? So the first one, the current one that we are right now, the closest one. And then we're going to let's just create a for loop that goes, let's just say that we want to render the 20 sections ahead of us, right? 20, 30, you pick how many sections you want to see. So I equals to 0, I less than 20, I plus plus. I have to say u short I have to declare this variable. So 20 times I have to go and I have to say before I finish that the current section is equal to the current section next, right? So next, 20 times in our case. What do I have to do 20 times? Well, I have to ask to render section. Is it render section the name? Render track section. So track section expects the track, the section, the camera, and the distance magnitude. We're going to have to change that. So render track section expects the track, the section, which is current section that I'm visiting one by one, and what else? The track, the section, the camera, and the distance magnitude. So I just have to pass the camera that I passed and the distance magnitude. But this thing right here, we are not going to use the distance magnitude to go and compute the depth. Remember how we have to go and compute how many subdivisions we have? So what I'm going to do is I am going to change this parameter since it is not based on distance anymore. Let's just change this thing and say that this is going to be a u short number of subdivisions, which, think with me, the number of subdivisions is going to be super easy because I can just decide based on this I index which ones are going to be subdivided once and which ones are going to be subdivided twice, and etc. So I'm just going to do something quick and dirty here. If I is less than, let's say, 6, then my number of subdivisions is equals to 1. So I just subdivide once. But if it is less than 2, right? So if my I is less than 2, then I'm going to subdivide twice. And then I pass the number of subdivisions as parameters. Let me just declare this one as well, num subdivisions. Does that make sense? So just before I pass the parameter, I already pass how many subdivisions I want this track section to have, because it's based on the proximity of my ship, which is this index from 0 to 20. I'm just going to subdivide everything that is less than 6. I'm going to subdivide once, but if it is less than 2, right, so if they're really, really close to me, I subdivide twice. Right, so I have to just change this parameter. So this is going to be number of subdivisions. And I think it is as easy as, right here, depth, right? So the depth, instead of having the depth here based on the distance, I can just say that the depth is equal to the number of subdivisions parameter. I didn't have to have this depth, but since I'm passing the depth here, I'm just going to force the parameter equals to the number of subdivisions. This is how many times we're going to subdivide the depth we pass to this render quad recursive function. Cool, so I think that's it, right? It makes sense. Let's see. Oh, I have to probably just change the prototype of this one. Let me just come here and track.h. Oh, I don't even think this is in the prototype. Cool, so we don't even need to worry about that, right? This is just a function from this file. Right, let me see if I forgot something. Let's just build. Oops. So track.c29 ship undeclared. I think I know. Right, so do you see how we are trying to start the current section with the ship section, but we don't have the ship path right here? And I don't think I can because of the include. So I'm going to say that we have something called section pointer start section, and we just pass the start section, which is the ship section right here. And this is going to be start section. So we start with the start section, and then we visit each one of them 20 times. And then start section in our main.c, render track ahead, I need to pass the start section. Who is my start section? Ship section. Dot section, right? Because ship at this stage is not a pointer yet. Cool, that's it. Let's see how this looks. So we should see our ship and all the tracks just ahead of us. Okay, so that is good news. If we move, oops, we have a couple of artifacts. So, right, so since we're just rendering things in front of us, you see how we have this empty track sections here close to the camera, right? So we're gonna have to just fix that. You know what I'm going to do? I'm going to make a judgment call and say that whenever I render my track ahead, this is going to be ugly, but whatever, right? So whenever I render my track ahead, besides looping all the sections in front of the ship, I am going to loop, let's just say 1 or 2 sections behind, so we actually render things that are closer to the camera. I think I'm going to do that, because loop the sections behind the ship, and I don't want to render 20 sections behind. Let's just render 3. And then, so if I is less than 3, the number of subdivisions is 1. If it's less than 2, the subdivisions is 2. And then render this current section. Right, so 2 things that I have to change. Here in the for loop, the current section is the current section previous, right? So because I have to go from the current one back. And this is start section. I don't want to render again the start section. I want to render the start section previous. So this is the current section, right? I already go to the previous one. Does that make sense? So we don't draw things twice. Cool, let's see how this looks. But I also saw a couple of artifacts. I have a feeling that we have some overflowing stuff still we're gonna have to fix, but let's see if this at least is fixed. All right, so if I accelerate, and if I move, all right, so we are rendering the things that are closer to us, so that is good news. I don't know if you noticed that we have a couple of some overflow happening. I have a feeling that the camera limits, right? So that radius of the camera visibility, remember how we were doing that overflow of 16 bits? I think we need to fix that before we actually do anything. I think we have to just clamp those values so they are within 16 bits. So in the next lecture, let me just quickly go and fix this overflow. I'm gonna think about this, see if I can spot where the overflow is, but I have a good feeling that that is exactly where it is, right? We are basically overflowing those values that should be within 16 bits. Some of them are more than 16 bits, right? So let's just try to fix that in the next lecture.